Hi folks, thanks for joining today. We're going to be discussing Enview, a VC-backed Silicon Valley-based company that spent the last 5 years developing a world-class research and development and software products engineering team. We've been investing directly in the science of geospatial AI and large-scale cloud-based processing. My name is Nick Ferguson. I've been in the LiDAR industry for 12 years, working across both software products and professional services organisations. Prior to Enview, I was Senior Vice President at Trimble Inc., responsible for NM Group's business across North America. So today we're going to be talking through common challenges experienced by geospatial services companies relating to the speed of delivery and the capacity to deliver. And this comes at a crucial time as the use of LiDAR is accelerating both across industrial and also consumer applications. We're also going to be covering Enview Explore, which is a software as a service platform that provides direct access to Enview's AI for automated 3D data processing. And this is working directly on the unstructured 3D point cloud data. So I hope you enjoy this webinar. For the purposes of explaining how Enview helps folks in the geospatial sector, I'd like to introduce you to a fictional character, Ops Director Powell, who works at a LiDAR services company. Powell has a tough job. He is responsible for the entire LiDAR value chain, from aerial data collection through data processing to delivery to end clients. His company has committed to servicing several customers and, with limited resources, Powell must prioritise which clients come first and troubleshoot difficulties to get the job done. Powell's job is made harder by the nature of the data he is dealing with. 3D data is large, complicated, and requires expert analysis. Advances in AI applied to structured 2D imagery unfortunately provide no advantage to Powell, as the assumptions that sit behind these break down on unstructured point cloud data. He must therefore utilise heroic levels of manual manpower to get the job done, and usually turns to outsourcing to low-wage countries. However, growing cybersecurity concerns are increasingly limiting his options. The bottlenecks inherent when scaling the company to meet the growing demands of customers is creating pain for Powell's team. Delivery dates are slipping and the customers are getting more vocal. Powell is asking staff to work overtime for the most recent project, but he's also asked them to work overtime for the last 4 projects. Staff burnout and churn is becoming a real concern. With late deliverables, angry customers are starting to withhold invoice payments, creating cash flow issues for Powell's company. There's an increasingly likely prospect of a round of layoffs after the current cohort of projects complete, which keeps Powell awake at night. To help Powell, Enview has developed Enview Explore, an automated 3D data processing platform. Enview Explore provides democratized access to AI and large-scale cloud computing. The system allows the user to drag and drop calibrated LiDAR files directly into a web interface. Explore then breaks this data down into thousands of individual tiles. It packages each tile in a container that has its own operating system and AI code, and allows people like Powell to call on the support of thousands of CPUs and GPUs to help them out. These are turned on and off instantly and scale elastically to meet the needs of the project. The user is able to automatically create deliverables and download these for delivery to a client or for additional processing steps in third-party applications. Examples of the automated analytics that Enview Explore provides include automated point cloud classification, feature extraction such as building polygons, the creation of surface models such as DEMs and DSMs, terrain change detection, building change detection, feature change detection including objects such as trees, and also things like object-to-object clearance, such as calculation of the distance between conductors and vegetation. I'd now like to show you Enview Explore in the flesh. First, I'm going to upload some data, so I'll go ahead here and hit New. I put in my dataset name. I then decide to drag and drop files into the browser. The system's going to automatically detect the EPSG SRID code, or I can select a horizontal and vertical datum. Once the data is uploaded, I can go ahead and create a project. So I go to the Projects tab, I select the data source, I give the project a name. I can either decide to reclassify the point cloud or keep the existing classifications, and also select the products that I want to produce. When that process has been completed, I can then come into my project, and if I want, I can choose to prepare a package for download and use in third-party applications, or I can switch to Enview's web viewer. In our web viewer, we have made this extensible, so we're compliant with OGC web mapping services. So an example I'm pulling here is the weather, real-time weather across the US. The system can also pull in a bunch of common file formats, in this case a Google Earth KML for my local neighbourhood. So let's have a look at some data for this, in this case 1 square kilometre of Vancouver. If we take a look, we can see it's done a really good job on the ground surface, also the buildings and the vegetation. The vegetation that Enview classifies is genuine vegetation. There's no fences or other objects misclassified. It's genuine vegetation. We can see as well the buildings across this highly urban area have all been automatically classified. On Saturday, I actually ran the whole city of Vancouver through the system with literally a baby in one hand and a laptop in the other. After uploading, it took 6 hours 47 minutes to process 7.3 gigabytes of data. That dataset was 44 points per square metre over 40 square kilometres. That had taken months using traditional workflows. Switching gears, let's have a look at a corridor dataset, in this case for a pipeline. Again, we can see that there's been a very good detection of ground, also vegetation and buildings, and the system will compute change over time. So we can do things like look at the depth of cover change over a pipeline. Of interest to pipeline operators, you can see here that buildings have been automatically detected. That's really critical for HCA classification processes, where the required depth and pressure of a gas pipeline is dependent on the local population and therefore risk factor for each mile of line. There's also a bunch of background mapping that can be brought in if we want to look at the topography, the local streets in the area and the hydrography. And again, there's also that OGC compliant web mapping service capability for pulling in things like water bodies and flow direction. Enview Explorer also has lots of helpful information, so each time we release an update, which is every 4 weeks, you can see the new features and any bug fixes. And there's also a very detailed quick start guide that provides summary information, also comprehensive detail on each aspect of the platform. So example here is dynamic terrain analysis and visualization in the platform. Enview Explorer therefore creates advantages for organisations that use it. Firstly, in terms of speed, we're several times faster than legacy methods. Because of the huge economies of scale that we are able to produce through utilising AI in the cloud, we can also classify data at a very competitive price, and that is inclusive of the massive improvements that clients benefit from in terms of speed. When it comes to accuracy, we're accurate. It's about 98.5% for vegetation, 93.5% for buildings, and about 84% for power lines, with further improvements planned. So what were the results of Powell? Firstly, he recovered lost time and was actually able to exceed customer expectations. This meant that the cash flow issues were resolved, customers started paying their invoices on time, and he was able to invoice ahead of schedule on the basis of the milestones being completed early. Powell's company also won more opportunities. The enhanced speed gave them a competitive advantage when it came to submitting responses to RFPs. Powell was also able to sleep at night and receive gratitude from his workforce. Enview Explorer is versatile across several industries. For example, use in electricity transmission distribution for managing encroachments, looking at change over time that may affect thermal ratings, looking at vegetation clearance to conductors, responding to hurricane threats. In oil and gas, it's used for things like HCA classification, geohazard detection, third-party damage prevention. In the military, there's lots of use cases, including hazard assessment and damage response. Enview has built out a really exciting roadmap in response to customer feedback. Soon we'll have road and water classification, along with things like vehicle and bridge classification. We're also enabling hydro enforcement and flattening. In Q2 next year, we'll have support for mobile and terrestrial LiDAR systems. Also things like self-service AI training, so that you can train up your own AI in a sandboxed environment. And things like synthetic training data, so the ability to deploy AI in a virgin territory where there's no previous training data and get really good, accurate results. Enview, of course, would be nothing without its people, and we're fortunate to have had the resources to build a team of world-class data scientists and engineers. The company was set up by Dr. San Gunawardena, who got his start building satellites for the Air Force, went on to do machine vision for safety of flight with NASA, and then did his PhD in machine learning at Stanford. After completing the PhD, he wanted to do something more practical with his time, so he ended up deployed in Afghanistan with the coalition forces. Whilst he was there, he saw the limitations of 2D data and the opportunities of using 3D data, but also the associated challenges and the sheer time it took to turn around data sets. So San saw this as an opportunity to help revolutionise the application of LiDAR, both in military circles and also industrial circles. Alright, so that's everything from me today. I hope you found this webinar informative and interesting. The proof really is in the pudding though, so if you'd like to have a go with Enview Explore, just ping me an email. My address is nick.ferguson@enview.com. We can set you up with an account in the space of a few minutes, and you can go ahead and push some data in and see the results for yourself. At Enview, we're also completely open to feedback, so if there's new features that you'd want to see in there, if there's additional capability that would help empower you as the user, we would welcome any kind of feedback that you're willing to give. So that's it from me today, and thanks once again. Bye-bye.